These notes are on something called the discriminant. So the first thing I'm going to do is I'm going to break up the quadratic formula into two fractions. So you'll remember the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I can rewrite that as two fractions, negative b all over 2a plus or minus the square root of b squared minus 4ac over 2a. And so when looking at this, I can see that, I'm going to have, as long as a and b are integers, this is going to be a rational number. And again, as long as a and b are integers, 2a is going to be an integer. So the question here about what is happening with what kind of answers I'm going to get when I'm solving a quadratic is really determined by the kind of numbers a, b, and c are when I write them as b squared minus 4ac. So let's think about this. So we call this the discriminant. So the b squared, square root of b squared minus 4ac is the discriminant. It discriminates whether or not, what kind of answers you're going to get when you perform the quadratic formula. So if b squared minus 4ac is a perfect square, then I'm taking the square root of a perfect square. So I get an integer. However, if b squared minus 4ac is greater than 0, but not a perfect square, then our solutions are irrational. If b squared minus 4ac is less than 0, our solutions, remember, less than 0, negative numbers. What's the square root of a negative number? Are complex. And if our solutions, so remember also, let's go back and just double check this. Remember, we have a plus or minus here. So if I have plus or minus an integer, I have two solutions. Again, plus or minus an irrational number, I have two solutions. Plus or minus a complex number, I have two solutions. However, if b squared minus 4ac equals 0, that means that this entire part of the fraction is 0. So that gets me an integer, and it is one solution. Which actually means, that our b squared minus 4ac is an integer. What that actually then tells us, I should have had a third column here, but that's okay, we'll just write it in here, that our solutions to the actual quadratic are going to be two rational solutions, two irrational solutions, two complex solutions, and one rational solution. So the two in the middle here, when we talked about our solution, we're talking about our solution to the b squared minus 4ac, the square root of that. That's what we're talking about when we're looking at the blue writing that I have here. And you'll notice that when the square root part of our answer is irrational, our answer to the quadratic is irrational. When our answer to our square root part is complex, then our solution to the quadratic is complex. But when our answer to the square root portion of the quadratic formula is an integer, or is 0, which is also an integer, that means that I have a fraction. I have two fractions. I have an integer plus or minus, a rational number plus or minus a rational number, which means that my final solutions to the quadratic are rational, not integers. The only way our solutions would be integers are if the negative b over 2a simplify from being rational to being an integer. Let's look at a few examples so we can make sure that we fully understand what's happening here. So when we talk about determining the kind of root or intercept that we're getting, we're asking, is it rational, real, complex, irrational? Like what is it exactly in terms of our complex number system? So each and every time I do these problems, the only part I'm going to pay attention to is the b squared minus 4ac. So I've got 4 minus 4 times a times c, which is 4 plus 40, which is 44. So it's positive, so I know I don't have a complex root, but it's not a perfect square. So that means that I have 44 is not a perfect square. So I have two irrational roots. In this case, being irrational means that they're also real, which means that they are also the x-intercepts. Second example, b squared minus 4ac, b squared, oh, I'm so sorry, I messed up the first one, excuse me. B squared would be 4 squared, which would mean that I would have 16 here. I'm so sorry. For those of you who caught this before I got that far, excellent work. So I have 16 plus 40, which is 56. 56 is still not a perfect square, so I still end up with two irrational roots. So back to our second example. B squared is going to be negative 5 squared minus 4ac, which is 25 minus 12 times 8. Well, that's a pretty big negative number, so minus big negative number, which means that we end up with a negative square root. So b squared minus 4ac equals a negative number. So we have two complex roots. Since these are complex, they're not intercepts. So I couldn't say that these are two complex intercepts. I could only say that they're two complex roots. Next example, b squared minus 4ac, b squared minus 4ac, 16 minus 16 equals 0. So because 0 means that the whole b squared minus 4ac part disappears, that means that I end up with one rational root or x-intercept. Our last example here, we have b squared minus 4ac, b squared minus 4ac equals 1 plus 8, which equals 9. So 9 is a perfect square, which means I have two rational roots or x-intercepts.